and welcome to the second of two lessons that you should be watching before the next class. This is modeling with expressions, so we're still focusing on expressions. So keep in mind that we talk about expressions, we're talking about math sentences effectively without equations. But what's this modeling part? What does it mean to model? You might be thinking of a fashion model, or you might be thinking of a model of a building that represents something bigger that engineers might use. But notice both of these are situations where someone represents something for others to more easily understand them. When we talk about modeling in math, we talk about representing a situation with an equation or an expression to better easily understand it. So let's go over an example of what I mean by this. But before that, just so you know, when we talk about modeling situations, we're talking about real world situations with sentences and paragraphs. And it's always important for us to understand what part of a sentence or a paragraph or information is important and what can be represented with math. So here are a few keywords. These are all on page 48 for you in your book. But addition can be represented as the sum of, added to, plus, more than. A big thing I want you to focus on is total. Addition always represents the total amount of something. Same thing with subtraction, being represented typically with things being taken away. Multiplication is usually represents the rate of change or a percent change. And division is more of a ratio. These are little key words that you want to keep in mind that will make your life easier when dealing with word problems. Now, let's go ahead and deal with example 1. So in example 1 right here, George is buying watermelons and pineapples to make a fruit salad. He buys W watermelons at $4.49 each and P pineapples at $5 each. Write an example to represent the total cost of pineapples and watermelon. Now, okay, probably already laughing and you're probably thinking, Mr. Porter, didn't you say that we would be using expressions to represent important situations, and why do I care about George's fruit salad? Guys, you have to understand that when you're in this class and when you're dealing with these situations, you're obviously not going to be paid money to do a job to do this, right? And you obviously wouldn't really want to go out of your way and set this up. But the idea is that we start with very simple and easy to deal with situations, and your goal is to build up this skill so you could eventually be dealing with wide vasts of data information to represent as an expression, and you can get paid quite a lot for that. But back to this problem. Whenever you deal with a word problem, you obviously want to focus on the keywords. I'm going to focus on the numbers. Numbers are always a good choice first. W watermelons at $4.49 each. P pineapples at $5 each. And of course, here's the question. We have to write an expression. Notice we're not solving it, right? We're just writing an equation. An expression. So right here, W watermelons at $4.49 each. That's $4.49 per watermelon, right? It's being multiplied. If it's 2 watermelons, it's 2 times the amount, right? And the same thing for pineapples. It should just be, if it's $5 each, it's P pineapples, so we have 5P. But the question is, how do we combine them? Do we do addition, subtraction, multiplication, division? Because we have to make a single expression. These are 2 expressions right now. But look back at the question. We're supposed to represent the total cost of pineapples. Remember what we do for total cost? Total cost is addition. So here's our expression. We're done. This is how much for watermelons. This is how much for pineapples. And that's how much it is combined. Let's do one more example. One that might be a little trickier. And yet it's kind of smaller. So as I read this, I'm going to do step 1 immediately. It saves me time. Identify key features of the word problem. Represent the following as an expression. That's our statement. That's our question. That's what it's telling us to do. Right there. The price of an item, that's important, plus 50% sales tax. So the tricky part is obviously the percentage, right? What do we do with that? So first off, the price of an item, let's just represent that as X. And that's going to be plus 15% sales tax, 15% of the total cost. And now you're probably wondering, this seems a bit off. Is 15% isn't 15 times bigger, right? How do you represent that in an expression for it to be 15% and not 15 times more? Well, when we put percentages into equations or expressions, we need to convert it into a decimal. And that's what this looks like right here. 28%, you could divide it by 100 and get 0.28. But notice all this is, right, is all we did was move the decimal over twice. So we could just put a decimal right here and move it over 2 times. And this is our answer. Now this is confusing you. Here's a hint. It says 15%, right? Notice this is also like 15 cents, as if it was money. So that might help you out a little bit. But 50% obviously is not bigger than 100%. So this decimal should most certainly be less than 1. I don't want us to go too hard into percentages right now, but try to use this little trick of moving the decimal over 2 times to turn any number into a percentage in an expression. Otherwise, this is completely done. We could combine this if we want to, but we'll leave it as it is. If there's any questions, guys, do please stop by during office hours. Otherwise, make sure you do those problems, and you have a good day.